Hey everyone, so in this video tutorial we're going to go over how to calculate contact forces. So in the first example here, we have a force applied to two boxes and the force being 50 newtons. How do we calculate the contact force? So first we have to understand that the contact force goes both ways according to Newton's third law. There's a force going right and a force going left between each of the two blocks. We have the first block being the 10 kilogram block and the second block being the 20 kilogram block. So next we know that force is equal to mass times acceleration. And we know that acceleration as a result is equal to force over mass. And so we want to find the acceleration of the whole system. So the total force of the whole system is equal to 50 newtons. So acceleration is equal to 50 newtons over the total mass being 30 kilograms. And this gives us an acceleration of 1.67 meters per second squared. Cool. Now we want to find the FC, the friction, the contact force, for each block independently, and these two should be the same, according to Newton's third law. So for the first example, we can do, let's do for 10. For the 10 kilogram block, we have a force hitting it from the left, that being the 50 newtons, and then we have the contact force hitting it from the right. So let's write like a net force diagram. The net force acting on 10 is equal to F, since it's going to the right, minus FC. And then F is obviously mass times acceleration, so MA is equal to F minus FC. And then let's just give us some more room here. And now let's isolate for FC. So let's move FC to the right, or to the left, by adding it. So FC is equal to F minus MA. And we move MA to the right by subtracting. And then if we substitute in, it's equal to 50 newtons minus mass, which is 10 kilograms, times acceleration, which we found to be 1.67 meters per second squared. And that would give us an FC value of 33.3 newtons. Now let's find the FC value for the 20 kilogram block. And it should be the same. And if it's the same, we know we did it right. So for the 20 kilogram block, we'll exclusively have an FC hitting it, a contact force hitting it from the left. Since as we can see, there's that 50 Newton force is only hitting the block on the left. It's not hitting the 20 kilogram block on the right. And if that's the only force we have hitting it, our net force equation is going to look a little different. It's going to be the net force of the 20 kilogram block is equal to FC. And it's positive because it's the direction the block is moving. So mass times acceleration is equal to FC. And then we can plug it in, 20 kilograms times 1.67 meters per second squared is equal to FC. And 33.3 newtons is in fact equal to FC. So as we can see, the forces of the contact force on both blocks is the same, meaning we did the question right. Okay, so in the next example, we have two blocks, just like in the first example, but this time the masses are 5 and 10 kilograms, and the force acting on them is 60 newtons. And the key difference is that now we have a coefficient of friction of 0.25. Now our first step is going to be the same thing for calculating the contact forces. We're going to find the net acceleration of the system, which is going to be equal to force over mass, which is going to be equal to force. Let me just clean this up. It's going to be equal to force minus the friction, the force of the friction, Fk, over mass, the total mass, And that is going to be equal to force minus mu k mg all over m1 plus m2. And now if we plug the values in here, we're going to get A, acceleration, is equal to 60 newtons minus 0.25 60 newtons minus 0.25, 15 kilograms. 15 kilograms, which is the total mass, times 9.81 meters per second squared, all over 15 kilograms. And our acceleration, when we put this into a calculator, will be 1.55 meters per second squared. And now that we have our net acceleration, we can find the contact forces for each. So the first one will be the 5 kilogram block. We're going to have a force acting on it, which is 60 newtons. And then we're going to have our contact force acting on it from the other side. And then we're also going to have our friction force. So our net equation for this will be F net is equal to F minus Fc, which is our contact force, minus Fk. And then from here, we'll expand out mass times acceleration is equal to F minus Fc minus Fk. In fact, Fk, we can write it as mu k mg. And then we're going to isolate for Fc. So to do that, we're going to add Fc to the other side, and then we're going to subtract Ma. So Fc is going to be equal to F minus Ma minus mu k mg. Sorry, that's really gross. Let me clean that up. Mu k mg. And then from here, we can fill our values in. So it'll be 60 newtons minus mass, which is 5 kilograms, times acceleration, which is 1.55 meters per second squared, minus 0.25 m, which is 5 kilograms, and then g, which is 9.81 meters per second squared. And that will give us an Fc value of 40.0 newtons. Now, to know we did this right, we have to see if we get the same thing for the other block, for the 10 kilogram block. And for the 10 kilogram block, the forces we have acting on it will be the Fc and the friction. And so our net equation, F net, is going to be equal to Fc minus Fk. And then to calculate for, or to isolate for Fc, we simply move Fk to the other side. So Fk plus F net is equal to Fc. And then we can fill the values in here. So we'll go for Fk, it's 0.25 mu k mg, so 10 kilograms, and 9.81 meters per second squared. And then for F net, it's mass times acceleration, which is 10 kilograms and 9.81. And all that is going to be equal to 40.0 newtons. So as we can see, once again, our contact forces for both the 5 kilogram block and for the 10 kilogram block are the same, meaning that Newton's third law, for every action there is an equal and opposite reaction, has been held true in this problem. Thank you.